Let's look at the following problem. A wagon wheel is shown below. Its radius is 0.4 meter. That means this distance, which is the diameter of that wheel, is 0.8 meter. The mass of the rim is 1.5 kg. So the rim is that part right there, and the mass of just that part is 1.5 kg. There are 8 spokes, and the spokes are 1, 2, 3, 4, 5, 6, 7, and 8, each having a mass of 0.55 kg and a length of 0.4 meter. You can see that these spokes lie along a diameter, like that. So they all lie along a perfect diameter. What you want to find is the moment of inertia of this wagon wheel about that axis. So that axis goes through the center of the wheel and perpendicular to the plane of the wheel. So let's start the calculation. The moment of inertia of this whole wheel has 2 contributions. The first one is the moment of inertia of that rim, and the second is the contribution from all the spokes. We have to sum them individually. So let's do the rim contribution. So that is the moment of inertia of this circular part of that wheel about that axis. The moment of inertia for such a construction is given by the mass of that wheel, which we know to be 1.5 kg, times the radius squared of that wheel, that distance right there. We know the diameter is 0.8, so the radius is 0.4, so 0.4 squared. The mass of that rim is 1.5 kg, and that's going to give you 0.24 kg meter squared. So we have the first contribution. So the rim part contributes 0.24 kg meters squared. Now let's determine the moment of inertia due to individual spoke. One example of individual spoke is like that. So we are going to assume that each spoke behaves like a uniform rod. So let's take a minute to analyze a uniform rod. Let's assume you have a uniform rod of length L and mass little m. You want to calculate its moment of inertia about its center. Now we know the moment of inertia of such a rod about that point is quite simply 1/12 times its mass times the square of its length. In our case, the center of that spoke is there, but we are interested in calculating the moment of inertia of that spoke about that axis. So in this diagram, we are to calculate the moment of inertia of a uniform rod about an axis passing through one of its ends. So since this length is L/2, by using parallel axis theorem, moment of inertia of a uniform rod about an axis passing through one of its ends is quite simply the moment of inertia of that same rod about an axis passing through the center, which is 1/12 ml squared plus m that distance squared, so L/2 squared. This is the distance between an axis passing through the center of mass and the new axis. And the sum will give you 1/3 ml squared. Applying this result to that spoke, we see that if little m is the mass of that spoke, which is 0.55 kg, and L is the length of that spoke, which is 0.4 meter, then this I is also the moment of inertia of each spoke about that axis in the middle. So there we have it. Now all we have to do is to sum over all the spokes. So how many of them are there? 1, 2, 3, 4, 5, 6, 7, and 8. So the total contribution from the spokes is 8 times 1 over 3 mass L squared, which is 8 times 1 over 3 times the mass of each spoke is 0.55 kg. That's given there. And its length is 0.4 meter, so 0.4 squared, which will give you a number of 0.235 kg meter squared. So the final answer is obtained by adding this number to that number. So the moment of inertia of the wheel is 0.24 plus 0.235, which will give you 0.475 kg meter squared. And that solves the problem. Thank you for watching.